Oh, hi, Alicante. Thank you. That's a very solid welcome. It's a signal that's going to go great. Yes, it's been a while we don't talk about signals, right? First talk, now a break. So who's ready for some more? Okay, that's it. Great. So, yeah, let's talk a little bit about that. But before, who am I? So my name is ATILA, or ATILA, or however rolls off your tongue. And I work as a senior developer relations engineer at a place called Crab Nebula, with Nova, the crab over there, and a bunch of very clever folks. And I'm also a Google developer expert for developer technologies. And because naming is hard, you can find me on all those things with different names. So I created a few shortcuts for you. So it's atila.io, and if you slash it to whatever place, you can find me, and I'll reply to you. The thing is that I just change names everywhere because naming is very hard. But yeah, what do I do on a daily basis? So I work at Crab Nebula, and we are a group of people that in the company, we have a lot of people that work with a framework called Tauri. Has anyone ever heard of Tauri? Yeah? Awesome, nice. And I see that some of you I haven't talked yet, so that's really good. So yeah, what Tauri is a framework for creating native applications. And it has the backend side written in Rust, which makes it secure and fast on the backend side. And the other component is a web view that basically allows you to plug in whatever framework you choose. HTML and jQuery, Svelte, React, Solid.js, whatever you want. So you can pick your poison, you can pick whatever suits you best, and go for it. And so that's the whole point. So that's why I like switching frameworks, and I like playing with all of them, because I like the plurality that we have in our ecosystem. So what I want to bring to you is a little bit of a follow-up of the conversations we've had so far. So Eric had a really good introduction comparing React and Solid.js yesterday. And then Chance this morning, we're talking a little bit about why he chose React, and he made a few comparisons as well. And the thing is, there's no right answer. And that's the point of this talk. So I clearly have my opinion, and I cannot abstain from saying my opinion because I don't know, I just have opinions about everything. But the goal of this talk is that to at least help some of you to make your own opinions and compare them and be able to have the conversation and pick the right one for you. So without further ado, let's talk a little bit about rendering things on the web. So at some point in the past, React came about with a bunch of really good ideas. The main one being the UI as a function of the state. And from that idea derived a lot of decisions and a lot of practices that we today consider best practices. So using rendering props and componentizing your UI and having a more declarative UI. There's more about declarative and imperative on an upcoming talk from Kyle, which is going to be great, I'm sure, and the unidirectional data flow. And the unidirectional data flow is one thing that motivated some of the decisions around the virtual DOM. Because ensuring the consistency throughout different components of your UI proved to be a little bit of a challenge on the web. Because essentially, ensuring this consistency made the DOM slow. And who has heard this before? The VDOM exists because the DOM is slow. Who heard that? Can I see some hands? Yeah, so I don't want to say that this is wrong, but I believe that this is an oversimplification of the facts. What's actually the full sentence is that making a bunch of removing and addition of DOM elements can be a slow operation. And that's the whole premise about the whole VDOM and reconciliation and abstracting the DOM layer so you can make the changes in a different environment and then hit in your DOM and make all the changes at the same time, so batching them. So that was the whole premise. Yeah, so the idea came on, you abstract the DOM, you batch the changes, and then you reconcile. Simple enough, right? So this is like something we have seen before a few times, I guess. I don't want to over-explain things, but just for to make sure we are all on the same page here, what happens is we have this root component, and the root component has two props that it passes down to their children, and then it branches out. Some children use prop A, some children use prop B, and there's a children there that's not using anything. What happens when props A changes? As you would expect, the components that uses props A are going to re-render, right? But all the others also re-render because in a way to ensure this consistency and make the componentized UI, React has decided that with the virtual DOM, you're going to couple the data and the rendering logic together. That's what Chance was saying in the first, he mentioned on the first talk of the day, and that's how React works, essentially. So whenever there's an update on state, to ensure that you always have the right and you don't have any stale data, you're going to toss everything that uses that state and render it over again. So because the change happens on the top layer of the component, everything re-renders. Cool? Cool? Yeah. So when I put like this, I think it looks straightforward enough. But it doesn't, I have noticed that it's not that straightforward when we toss context in the scene. Because with context, we can avoid the prop drilling. And then suddenly, for some people, it's not a direct connection between your root component and the child component. So in this case, what happens if we re-render the root component or the component that has the context provider in this case? Everything re-renders. And that can be a potential foot gun if you have, for example, a big provider with a bunch of data that's wrapping your entire app. So things can get a little bit out of hand sometimes here. But yeah, let's not forget about memoization, right? That's why memoization is there, because then we can decide, okay, so this component, I don't want to re-render if I'm going to not touch that specific prop. And then I can persist it. But there's also an issue if you just go blindly memoizing everything, because you don't want to premature optimize your stuff, especially if you don't need it. And as mentioned before, there's something called React Forget. So this is React Forget still in RFC. We haven't seen it in play. But my understanding of React Forget is that it's going to be compiler level auto-memoization that's going to be able to then, because it's on the compiler level, it can have some bigger introspection into your code and define, okay, so this component depends on this prop, and then we can memoize and define what are the dependencies. So then we only re-render said component if the props that they depend on re-render, regardless of what happens to their parents. So if their parent, on our first example, has the props A re-rendered, we ideally should not render everything else. So it's going to create this little blocks, like little blocks of memoized branches where you can define what depends on what. So whenever props A changes, you have the pink block re-rendering, The green is only re-rendering if their own stuff re-renders, and the blue one only for the props B. So that's the whole point. And that's a very nice optimization. There's also, like, though React forgets not available to be used, there's a library called Million.js that's new rendering engine, I'd say, that you can plug in on your React app that creates something in practice similar to this. It's basically create these little blocks of VDOM that are gonna optimize, in this case, and essentially scope your re-renderings. So you can get a result similar to this. Though this is not the same as what signals are, and we are gonna talk about that in a minute. But first, I need to show you a counter. Again, I'm sorry, and I'm gonna do a flex on Tejas and Eric, because I'm not gonna show you one counter, I'm gonna show you two. So what's happening here is, like, you cannot get too creative with a counter, right? So what I have is this counter component. I have my state, and I'm setting the state on click and just incrementing it. As Eric showed you, if you remember, we're using the callback method for state because I'm cutting that short. And then I have two components that get rendered by their parent. So I have everything running. Let's refresh it. So what you see here is both components got rendered because, of course, I just mounted everything. You're seeing them twice because, as Chance already mentioned, on React development mode, renders runs twice because there is one reason for that. They want your components, they want to ensure that our components are atomic. So use effects is going to run twice, and all the rendering runs twice in terms of defining, helping you keep them atomic. So you're going to see things twice, but that's expected. That's not happening in production. The thing that I want to show you, though, is considering, yeah, we already rendered everything, and now once we change something, because in the parent, every time I change the one, second reruns, which is precisely what we've just seen, right? Because that state change is happening on the parent, so then the parent re-renders, everything re-renders, exactly how we saw on that contrived example. The solution for that is memo. So let's see how hard it is. So let's go const, and I'm going to call mCounter because I already said I'm bad at naming, and I'm going to memo my counter. Great. So now I'm going to just replace my second counter with the memoized version. Save, refresh. Again, both of them rendered because it's the first time. I clean my console. And now if I run the second one, both of them run because only component number 2 is memoized. So if the prop that counter number 2 depends on changes, it re-renders. And because the parent re-rendered, the first one re-renders. But now, if I update the second one, only it re-renders. So that's the whole point of memo. And OK, it works. And let's go back to my thing. But yeah, cool. So again, yeah. But it still re-renders more often, or in this particular case, it still re-renders more. It still does more work, I mean, because I'm re-rendering the whole component, so I'm evaluating the whole thing. And as a rule of thumb, I consider memoization to be a technique to avoid the big re-renders, because re-rendering itself is not usually a performance bottleneck for React applications. It's when you have a very heavy computation in the middle of your tree And that causes a lot of rework, and that consumes a lot of stuff. So what we want and the premise of using signals is not just to avoid re-rendering, is avoid unnecessary work. And when we talk about avoiding unnecessary work, as a hacker, React developer, you're thinking, okay, so avoiding work is use ref. So I just store something in ref, and it's going to persist across a lot of renderings, right? So yeah, maybe we can get somewhere close to signals with use ref. So there is work. Wake up. Yeah. My laptop's also hungry, I guess. Oh, there you go. So useref is good because it can help you to avoid re-rendering data that's the same. But the issue of useref in this case, and what makes it fundamentally different and unfit for this use case, is that it cannot trigger a re-render even if it wanted to. So because of this, because Memo still cannot prevent some of the execution, some of the processing to do, even by preventing excessive re-renderings. And useref cannot trigger a re-render based on the data you want to change. Some ideas are starting showing up to challenge the VDOM approach. And this is important to point out that because React is based on the VDOM and the whole architecture of React is based on the VDOM, there are hacks around for us to use signals in React, but it's basically when you mix two different mental models, and then, in my opinion, is when you put some landmines for you to step on in the future. So there's some ideas, and that's what framework war, I really don't like this, because it should be like a framework tide, because we're all learning from each other, and the whole point is of having this kind of difference of different ideas is that we learn from each other and we all better for it, right? It's not about picking a club and going for it. And so, okay, so what's the alternative of the VDOM, right? The alternative is that if you render things only once, you may not need to batch the changes, and you can, if you're touching only what has changed. Because as we've seen, the problem is removing and yanking stuff from the DOM and then putting them back on. But if we're just switching data, we're not actually restructuring the DOM. So there's less work involved, a lot less work. And so let's go for another counter. But this time, it's going to be exactly the same. But then we're using now solid, and just a pointer, like all the talks about signals have talked about solid and put solid React because, yeah, it's a React conference, so React is the common denominator here. But also, not only because of that, but because React is one extreme of the VDOM and solid is on the other, and we're going to see later where the other frameworks are, kind of, more or less. But they're essentially in different extremes. It's not something, there's no polarity in this case. But the point that I'm trying to make is whenever you have a solid app running, you render everything. And again, it doesn't need to worry about your renderings being atomic because you're only rendering things once. There's no re-renderings involved because now if I clean things up and I change my stuff, only that value is switched because, and that's why signals need to be a function, because every time that function gets recalled every time you're going for a getter, and then it fetches from wherever it's stored and brings it back to the DOM. So you're not taking out the span tag or whatever, the button tag, and putting it back on. You're just switching the text content of that. So because solid is not re-rendering, it doesn't need to have that difference, and then even when we're rendering for the first time, things only render once, and then once they're rendered, they don't need to they don't need to go again. So that's essentially the only difference that we have in this code, as you can see. So I'm just using the same thing, creating the signal and everything else. So they're roughly similar, as you've already seen on Eric's talk. But fundamentally, they work completely different ways in the way of defining what's going to be rendered and not. And let's look why. No. So, yep. So signals are an implementation of a design pattern called the observer pattern. And what does it mean, the observer pattern? In a nutshell, of course. It means that we have the data, and this data is going to notify, okay, I changed. So once that data notifies it changed, the component or whatever is using that data is tracking that data or subscribing to that data, if you will. And it's going to realize, okay, the data just told me it changed. And then the rendering pattern is going to take that and apply the changes to that data specifically and surgically. And if you've been around for a while, you know that this whole idea of using the observer pattern is not new. It started probably with Knockout.js, but then there's other applications of the observer pattern, one of them being RxJS. Who has used RxJS? Just so I know. Okay, great. So yeah, let's talk about that because we're talking about observer, and that's essentially a data handling or reactivity library that you can essentially plug and play. It has had very good support in Angular for a long time. It can be used with React and everything else. So what's the point? What's the point of having a whole rendering engine dedicated to signals if I can just plug in RxJS and go my merry way? Well, they have a very fundamental difference between signals, and that's why even AngularJS, who is very easy to integrate with RxJS, also adopted signals. By definition, and that's I took verbatim from their website, the documentation, they are a library for reactive programming using observables to make it easier to compose asynchronous or callback-based code. Asynchronous being the keyword. Signals are fundamentally synchronous because if rendering of your UI depends on signals, they need to be synchronous because you need to be able to queue them with ease. But there are more differences than that. So observables, first, they have cold start, which means they are only going to emit data if there's a subscriber to it, which means that if a component, some data has no subscriber, they're not going to emit changes, which means you can lose state if you depends on it, if your app depends on it. They're push-based, which means they emit data as soon as available. That's fine. And they're unicast. So each subscriber has its own stream. So for building UI, we can already see that, like, for depending our whole UI, we can already see some edge cases where they're not going to fit, right? Because signals, and I put the solid there because that's the kind of signals that I know better. So there might be some nuanced differences between how Vue implemented their version of signals, Svelte runes, or AngularJS signals. There might be some difference, so I just don't want to put my hand on a fire and get burned. So I'm talking about solid in this case. Solid has hot start, which means the data emits, the data can emit it before have any subscription, and they're essentially multicast. So multiple subscribers can listen to the same data source. That's really good because that's usually how UIs work, right? So that's it. That's the difference between signals and observers, and that's how signals can work in order to help us build the UI. But that doesn't really explain how we avoid the rendering and how it implements as a position to the VDOM pattern, right? So when we're talking about using signals, the component is just a function, like components are just functions in every framework essentially, but in this case, they are like just a little abstraction layer for us to co-locate things, but fundamentally the render and the data are separate. So signals handle data, they don't handle rendering. So that whole idea that the UI being a whole function of the state kind of still applies because we have control flow patterns and whatnot, but it's a little bit different in the sense that you can handle the rendering and you can handle the data. Sort of like that divide that Eric did on his talk, which I thought was really clever, but I didn't make notes about on mount and then the template. So that was a really good mental model. And essentially, this is summarizing it in a more graphical way. You have the render and you have the data. So in this case, it could be like the JSX and the function body. And yeah, so I need to have a snarky comment in this case, now that we're wrapping up our understanding of signals. So my friend Christopher asked this question, and I just, made a bad joke. But that's usually where discussions end, right? We say our piece and we say, oh, I have a great idea, that's how you go, but I need to be fair with everyone, and now let's talk about the trade-offs from somebody that really likes signals. What are the things that I stepped on that I hope you don't, if you decide to come this way? So the first thing is obvious. It's the first thing that we as React developers fall. If somebody that wrote a solid component or any component that uses signals says they never fell for that, they're lying, which is you cannot destructure it. And it sounds simpler, but then at some point muscle memory kicks in and you do that and the thing just doesn't work and you realize. Luckily for solid.js, there is like a linter for that and your IDE just shouts at you when you do something like this. But that's such a common issue and something that we say all the time that I decided to put it as a separate rule, as its own slide. But essentially, reactivity is a fine-grained reactivity, in this case, is very delicate, which means, especially when you're talking about solid.js, it's easy to fall off. It's going to explode in your face. In terms of the whole idea of VDOM is that it's very resilient. It's the premise of React is that it's going to help you ship faster. So if you write something, maybe you didn't write the best way possible first, but it's going to render and it's going to work. And maybe 5 years from now, you have some performance bottleneck and you have to pay the technical debt. That doesn't work this way in Solid and we're using signals, because if you fall out of reactivity, your UI doesn't update. And you're going to see that immediately. So this is a big trade-off, and it's something you need to be aware of if you're going to adopt this mental model, is that it's going to whip you if you don't follow the best practices sometimes. But if you're not, there's a bunch of helpers. This is a non-exhaustive list of them. This is just the ones I chose to bring. Some of them you've heard, you've seen before in this conference. And I'm going to bring, and I brought some new ones just for, So, okay. So the first two are the for and the index. They are essentially for list iterations, and 9 out of 10 times you're going to use for. The index is for more specific cases, but essentially what they are there for is if you have the common UL mapping through an array and showing you stuff, it's going to protect you from re-rendering the whole thing, because that's something we don't want. When we adopted a framework, we adopted a mental model to avoid re-renderings, so let's do that, right? The second one is for control flow, so you're already seeing that. You have show, where you define essentially those little conditions. They replace the ternaries. And the switch and match are a very nice pattern matching. Once you get used to it, you get addicted to them. Next, we have the first helper, which is the on helper, similar of an event listener. That helps you whenever you have to manually define the tracking of dependencies, because solid signals will do the auto tracking for you 95% of the cases, but there are going to be sometimes you want to say, okay, so this is a prop that I want you to track for this specific effect, and then whenever this thing changes, I want to rerun this thing. So on's for that. Create effect is for handling some side effects. Create store is a very nice synthetic sugar, because dealing with arrays and objects and signals is extremely convoluted, I want to say, because we need to store every value in its own signal and etc., because then you can trigger the updates towards them, and it kind of helps you also tracking everything. So the store is going to help you creating a proxy for them and tracking the changes. So it's really a lifesaver dealing with reactivity if you have like a list of data that's dynamically changing or an object. Then we have create resource. That's for asynchronous methods. So if you're going to have like a fetch request or something like that. And then because signals fire immediately, sometimes you know you're going to trigger a bunch of signal changes, and that's more work than necessary. So sometimes you want to go in the way of batching routes, so you can manually do that. So if you have one user interaction that's going to trigger a bunch of different stuff, you can batch them and make sure they execute only once in this case. But to finalize the trade-offs, what's the main takeaway I want you to get from this? There's no free lunch. However, whichever tool you decide to use, we need to understand how it works, because all of them are going to have some pitfalls, and all of them are going to have things we need to prevent against, and things we have to keep in mind. But that being said, there are different increments of reactivity. It's not a linear thing. It's not either you go full-on signals or you go full-on VDOM and so on. So how does it go? How does it work? So first, we started, they were in different ends of the spectrum. So you have Solid and React, and the other frameworks were somewhere in between. And then creator of Solid said, okay, I love signals. Let's talk about it. And a few streams later, a lot of articles later, a lot of benchmarks later, it kind of worked more or less like this. So pretty much all frameworks have their own flavor of signals in a way, and their own strategies to handle signals. Some are more resilient, some, if you fail reactivity, it's going to re-render the whole thing, some don't. So there's a way to do it. And yeah, so essentially, this is how each of the frameworks react. And that's it. That's what I had for you today. I hope you enjoy your lunch. And I'll be around to talk about it. And you can find me on wherever you are. Thanks.